Previously, let me introduce myself. My name is Christian Agusta, and here is my colleague Makayo Kanaka. And today we are going to present our research before, which is pneumonia detection using deep learning and machine learning. First one, my friend here will try to present it first.
In summary, pneumonia is a leading cause of death in children under 5 years old. This disease is rather difficult to detect because it mainly affects the lungs, which cannot directly be seen. Usually, we detect it by using a chest X-ray and then analyzing the images uh, by an expert. And to help this process, there have been efforts to create a deep learning model that can analyze the images and then diagnose pneumonia. To further this research, we propose an ensemble deep learning model composed of VGG16, exception, and EfficientNet V7. We have found that while the ensemble model composed of exception and EfficientNet V7 does increase the accuracy of its components, it still does not reach a higher accuracy than the highest performing individual model, that is VGG16. Right, into the introduction, pneumonia is a leading cause of death for children under 5 years old. And detecting pneumonia is difficult because it requires a chest X-ray and an expert analysis. To alleviate the efforts of the expert, we propose an ensemble deep learning model composed of VGG16, exception, and EfficientNet V7 that could analyze and diagnose pneumonia. There have been efforts to increase the accuracy of the models. One such method is using ensemble learning. It's by combining deep learning models into a single model that in the hopes of increasing its performance. One such proven example is by combining ResNet 150 and ResNet 101 to create a more accurate result than its components. Next.
Okay, and I will present about the methodology we are using. The first step before we are making our model, we are importing our dataset first. The models are trained using chest X-ray image in children, which composed of the healthy ones and the pneumonia ones. Then, after we are importing the dataset from Kaggle, the dataset is being pre-processed, like being turned, being shared, and being other process to be cleaned and to be labeled. Okay, after the image is being labeled, the image is divided into few folders like training and testing to divide the dataset so we can use it for the different purpose. After we are dividing the dataset, we are training the models and testing the models. And after making the test, we are combining of few models using making an ensemble models by voting method. The result we are getting is the first one. We are getting an accuracy of VGG16 by 86.9%, exception 80.51%, and efficient net B7 by accuracy of 83.23%. That is the result from the first experiment we are trying. After trying the individual models, we are combining, which making the ensemble model one, which consists of VGG16 and exception, and getting an accuracy of only 77.35%. The next one, ensemble model 2, which consists of VGG16 and EfficientNet B7, we're getting an increasement from the previous model, which we are getting 79.43%. Okay, for the last one, which is ensemble model 3, we are combining exception and efficient net B7 and getting an accuracy of 84.23%. And from both experiment we are getting and we are trying to make, in conclusion, it can be concluded that ensemble learning, like other deep learning models, has certain compatibility. Using ensemble learning doesn't necessarily mean that the combined model will provide higher prediction results and accuracy. Many experiments are needed in tuning each model and seeing the suitability of the model in making predictions to ensure that the learning ensemble form provides satisfactory results. And combining deep learning models may not improve their performance. Further research into ensemble models can be done to find reason behind this and what can be done to ensure that the models create satisfactory results. It needs some tuning and some trial and error method to find the best suitability for every model and every dataset. And here is our presentation today about pneumonia detection using deep learning and ensemble learning. Thank you.
Thank you for watching.